Alright, so for part two, with this, we're going to take a look at OF2. If we do the math, there's three things that would love to have 8, so 24. 6 plus 14 is going to give us 20. 20 minus 14 will give us 4, or 2 bonds. We're going to have our oxygen in the middle. And then it's going to be surrounded by fluorine on each side. We're going to make the fluorines happy. Whoops. Kind of off the page here. And then we look to see if it's polar or not. So we're going to find out if there's polar bonds and oxygen to fluorine. Let's look up a difference of electronegativities. And our difference is 0.5. So that would make it polar. So there is a polar bond. And there are lone pair electrons in our central atom. There are, so the molecule is polar. Get lost here. Anyway, okay, so the molecule is polar. But we don't have any polar molecule, yes. Hydrogen, oxygen, hydrogen and nitrogen, or hydrogen and fluorine bonds. Nope. And so therefore, we've got dipole-dipole interactions going on. Let's get back to this guy. So, dipole-dipole. Why? Because it's polar without hydrogen to fluorine, oxygen, or nitrogen bonds. So take a look at NH3. If we do the math, we're going to find out that we need 3 bonds. And we've got lone pair electrons on our nitrogen to make it happy. And so if we go through our flow charts, we would find out, well, first we have to check out our difference in electronegativity. Nitrogen's 3, hydrogen's 2.1, so we're going to end up with a difference of 0.9, so that would definitely make it polar. So it's a polar molecule, and, well, polar bond, so other polar bonds, yes. Lone pair of electrons in our central atom. Yep, so the molecule's polar. Type of force, well, we looked at this flow chart. Is the molecule polar? Yes. Are there hydrogen to oxygen, hydrogen to nitrogen, or hydrogen to fluorine bonds? There are, so we're going to make it a hydrogen bond. And that's because it's polar with hydrogen to, in this case, nitrogen bonds. Alright, let me make some room over on the side. Let me erase some of this stuff here. And we'll take a look at HF, hydrogen fluoride. We do the math, we're just going to need 1 bond. We're going to make the fluorine happy. And if we take a look at our difference of electronegativities, 2.1, 4.0, it's going to give us a difference of 1.9, so that's definitely a polar bond. And if we take a look at if the molecule is polar, well, polar bonds, yes, lone pair of electrons in a central atom. Well, it's not really a central atom, but there's only 1 bond, and that 1 bond is polar, so it's absolutely a polar molecule. So we go back to this flow chart. Is the molecule polar? Yes. Are there hydrogen to fluorine bonds? There are. So that means we're going to go down this way, and then there's going to be hydrogen bonding. So this is going to be H bond, because it's polar with hydrogen to fluorine bonds. And this last one, phosphorus trifluoride, we're going to have phosphorus trihydride. Phosphorus with 3 hydrogens around there. We're going to look to see if our phosphorus to hydrogen bond is polar. It is not. So let's go and take a look at our molecule flow chart. Polar bonds? Nope. So that means it is going to be non-polar. And anytime it's non-polar, we've got just dispersion forces holding it together. So we're going to have dispersion / London. I don't know why I just spazzed there. Forces, because it's non-polar. That's it. So that's how we do these. So aside from the top part of this with the vocab and stuff, all we have to do is figure out if the bonds are polar or not. So good luck.